Hello, welcome to the first lesson of the Redox unit. The question of the day: what happens to electrons when sodium and chlorine make a bond? Make sure to be very specific. All right, all the way back to the bonding unit. An atom becomes an ion by either gaining or losing electrons. Literally right here we have sodium and chlorine. Sodium is giving away one electron, it loses one, and chlorine is going to gain that electron. They form a positive sodium ion and a negative chloride ion. Gaining and losing electrons has their own names. Anytime electrons are gained, we call it reduction. I know that sounds weird, but this is why. Electrons, remember, are negative, and gaining a negative is going to make the charge or the oxidation number on the species, on the substance, on the atom, it's going to drop. That's why we call it reduction. So in the case of chlorine, we have a chlorine atom with a zero charge, same number of protons and electrons, gain one electron, become a -1 ion, and because the charge dropped, they named it reduction. But it's because you have gained electrons, it's because electrons are negative. Oxidation is the opposite. Oxidation is the loss of electrons. So when you lose electrons, you're actually losing negatives, so your charge or oxidation number is going to go up. They thought originally it was related to oxygen and found out it wasn't, but they had already come up with the term oxidation, so they just kept it. So we have sodium the atom becoming sodium the ion. The charge goes up because it has lost electrons, and that is oxidation. The oxidation state effectively is charge in chemistry. The law of conservation says that reactions have to be balanced in terms of mass and charge. Up until this point, we probably were just focusing on mass, and this time around, we're going to make sure that the charges are balanced as well. Sometimes in our redox equations, we do write electrons to show how they're moving around, and other times we don't. It is important to remember, though, that atoms are neutral because they have the same number of protons and electrons. So this is how we track electrons. We use these things called half reactions. We're going to get into them way more later. But here we have a magnesium atom losing electrons to form an ion. So the electrons here are a product of that reaction. They come out, and the oxidation state of magnesium is going to rise. So this would be an oxidation reaction. Using this as a model, see if you can fill in these equations to figure out if each species was either reduced or oxidized. I'll give you a minute. All right, we have iron plus 3. So an iron ion is gaining 3 electrons because it's in the reactant side. It gains 3 electrons and it becomes an iron atom, rather. And because the oxidation number dropped, it went from 3 to 0. That is a reduction. Next, we have 2 aluminum ions becoming 2 aluminum atoms. In order to do that, it had to gain electrons. The other way to look at it is that the plus 3 became a 0, so that is obviously indicative of a reduction. Then we have a copper atom becoming a copper plus 1 ion. In order to do that, it had to ditch an electron. Remember, electrons are negative, so if the charge is positive, that means we have fewer electrons. For that reason, we are losing electrons, making this an oxidation. So those little reactions are called half reactions, and they are going to show what happens to just one species or one substance during a chemical reaction. So in this case, those were half reactions. We are going to talk way more about those later in this course, so make sure to subscribe so you don't miss that video. They're actually really kind of fun. I like them a lot. Okay, so redox is a lot. It's a lot of memorization just because we gotta remember which term to use for what occurrence. So there's 2 memory tricks. I have always used Leo says GER, where LEO stands for lose electrons oxidations and GER stands for gain electrons reduction. I know there's a lot of teachers out there that prefer oil rig. Oxidation is loss and reduction is gain. So either of these will work. Just pick which one that you like best. But this is really going to help moving forward because redox is a lot of vocabulary to keep straight. So make sure that you feel comfortable with either of these acronyms. That is everything on Introduction to Redox. Please make sure, like I said, to subscribe so you don't miss the half reactions lesson and so much more. Please leave any questions you have in the comment section below the video, and I'll see you in the next one. Bye.